Hello, I'm Robert Baker.
Jesse Barnes.
We're determining the heat loss of my house. It's a manufactured house, nice square shape, nothing crazy. Temperature outside right now is roughly 32 degrees Fahrenheit. Inside the house we're keeping it at a nice 70 degrees. What we've done here, we're calculating the loss of my home based off of the type insulation that we are assuming. We're also making a few other assumptions, such as we're not calculating the windows in the home. The mass is constant, and our insulation we're assuming is R13. Throughout the whole house, we're just assuming that it's just 100% insulation. So what we have here is our area of the home, which we've determined based off all the walls, the roof, to be 2,830 feet squared worth of walls. We have the temperature difference inside to outside, and we have our R13.
It is the thermal rating value of a wall.
Of the R13 insulation. So right now we're calculating a loss of 8,273.21 BTUs an hour.
Alright, so now we're dealing with the actual home heating loss. Before we were dealing with the theoretical. So here we have all of the givens before. What we added was the K value. This is based on paper-faced insulation, which has a density of 1 pound mass per feet cubed. And then also the insulation is 4 inches thick, or 0.3 feet. So here we have a thermal conductivity equation, which is K value times the area times the difference in temperature over the distance change, which is that 0.3 feet. So we have the 0.026 BTUs per hour foot Rankine times the surface area times this temperature difference over the 0.3 feet, and we get us to 9,320 BTUs per hour.
And that's the actual loss of the house, considering the windows and the gaps and all those small holes and losing heat.
Now we're doing the insulation efficiency. Now we have theoretical over the actual. Both of these, the flow rates we just calculated, which theoretically 8,273.31 BTUs per hour. The actual 9,320 BTUs per hour, and then the efficiency would be 88.8%.
So here we have our furnace input and cost. We ran the furnace for a while, timed it, how long it would keep the house at a constant temperature of 70 degrees. In that time, of course it's still really cold outside. It ran for 420 seconds, and then it was off for 810 seconds before it kicked back on. We just kind of extrapolated from this. The output of the furnace is 22 kilojoules per second. We multiplied that times the time that it ran, giving us an output of 2.566 kilowatt hours. We then opened this up for the full hour, the time it ran, the kilowatt hours, and how much it would have ran, and how much power it would have used. 7.51 kilowatt hours per the hour. We then opened this up for the month, so it ended up for the whole month. If it was to run constantly, if it was constantly 32 degrees outside and we ran it constantly at 70 degrees, we would end up using 5,407 kilowatt hours per month. Again, this is assuming it's constantly on. There's no other inputs going into the home, and the temperature is constantly 32 degrees outside. As far as cost to me, the RMC charges $0.1038 for 1 kilowatt hour. With the 5,407 kilowatt hours per month that I use, it would cost me $561 a month to run my furnace like this. that's not the case, hopefully, this winter.
Now we're looking at the home efficiency. So before we took the electrical work coming in per hour, which is that 7.51, we converted that to BTUs. To here, efficiency of the house will be what's going out versus what's coming in, which Q loss actual over the electrical work. So we have 9,320 BTUs per hour over 25,625 BTUs per hour. That all comes out to 0.364, which will be 36.4%.